The simplest form of movement is diffusion, which is when a substance travels across a semi-permeable membrane from an area of high concentration to low concentration. Diffusion also does not need energy and is related to molecular kinetic energy. Water moves through a semi-permeable membrane through the process of diffusion that is specifically called osmosis. Water moves from an area of high free water concentration and low solute concentration to areas of low free water concentration and high solute concentration. The purpose of the experiment is to find out which type of solution will cause the greatest change in mass. Our hypothesis is if the model cell is placed in water, then the tube containing sucrose will experience the highest rate of change in mass. The materials you would need are distilled water, 1 mole of sucrose, 1 mole of glucose, 1 mole of sodium chloride, 5% albumin, dialysis tubing, some clamp scissors, string, a cup, a balance scale, and a syringe.
Prior to the experiment, we needed to figure out exactly how many grams of each compound needed to be added to the water for there to be a ratio of 1 moles per liter. We used the formula mass over molar mass times volume to find the exact amount.
Now that you have gathered your materials, take 4 cups and label them accordingly as shown in the picture. Then, take a dialysis tubing out of the water bath. Fold over and tie or clamp one of the ends. Make sure it is tight so that the solution inside does not escape through the endings during the experiment. Next, rub your fingers to create an opening. Now take a syringe and measure 10 milliliters of the desired solution. Now put 10 milliliters of solution into the dialysis tubing. Now fold the end just like you did before, keeping in mind to clamp it tight enough so the solution doesn't leak out during the experiment. To keep it organized, put the dialysis tubing into its corresponding cup. Now repeat these steps for the next 3 solutions. After you're done with all the dialysis tubings, wipe off the excess water and measure the initial weight of each tubing. Make sure to zero the scale before measuring. Next, fill each cup with distilled water until the dialysis tubings are submerged. Now, wait for 10 minutes as the diffusion occurs. Measure the weight at this time and record it onto your data table. Do the same thing at 20 minutes and 30 minutes.
Based on the results, the cell in the sucrose had the greatest rate of change in mass in the beginning, but as time went on, it slowed down. Among the 3 solutions of sucrose, glucose, and sodium chloride, glucose had the lowest rate of change in mass. Meanwhile, sodium chloride had the greatest rate of change in mass since its molecules are relatively larger. As a consequence of their size, it takes glucose molecules a longer period of time to reach equilibrium. The glucose solution gains water, but not as quickly as the sucrose solution. Here, the rate of mass increases decreasing because the water potential of the solution is increasing, with the intake of water. When the water potential of the sucrose cell equals to the water potential outside of the cell, it will stop diffusing. Since the pressure is increasing, the water potential will become level with the environment despite the lack of solutes in the environment. The pressure keeps water from entering the cell due to the rigid structure of the membrane. In essence, the dialysis tubing membrane depicts a cell wall module. Here the cell wall will stretch until it reaches its limit, at which point it will stop intaking water. Lastly, albumin's rate of change in mass is increasing primarily because the solution is very concentrated, but it isn't receiving water at a higher rate than the other solutions.